Okay, we're back, number 14. Okay, so I'm finding the length of the darkened arc. So once again, the formula is you take the number pi, you multiply it by the diameter, which in this case happens to be 16.4, and then you multiply it by the fraction. The denominator of the fraction is 360, that's a whole circle, and then the numerator is how many degrees the darkened arc is, which is half of the circle, so that's 180. Okay, so once we get the formula, it's just a matter of plugging it into your calculator. So I'm going to take 180, I'm going to divide it by 360, that's 0.5, and then I'm going to multiply that by 16.4, I get 8.2 pi. And the instructions said to leave our answer in terms of pi, so there's the length of the darkened arc, 8.2 pi meters. All right, number 15. So I'm going to find the length of this darkened arc right here. Well, that darkened arc's measurement would be the same as that. You can see they're the same. So that would be 60 degrees. So to find it, the length of that arc, I would take pi. I would multiply it by the diameter. Now, because that 15 is set off to the side, that's implying that the radius is 15. So that means my diameter is going to be 30. And then I'm going to multiply that by the fraction 60 over 360. Okay, so 60 divided by 360 is equal to that really long decimal. Remember, don't round the decimal until you're done with the final problem. Multiply that by 30, the diameter, and we get 5 pi. So number 15 would be 5 pi feet. Okay, all right, number 16 through... Actually, let's see, it's through 23. We're going to be finding the area of the shaded sector. Okay, so in this problem, we're finding area of the sector. Remember, sector, whenever you see the word sector, think of it as a slice of pizza. So we're finding the area of the slice, of the shaded slice of the pizza. So how do we do that? There is a specific formula. And the formula that you can use is pi. Then you multiply that by the radius squared. That formula right there actually would give you the area of the entire circle. But then we need to just find a fraction of the circle, so we're going to multiply it by the fraction x over 360. And just like in the previous formula in arc length, x would stand for how many degrees the shaded part is. Okay? All right, so number 16, you can see we have a shaded part. Well, it's 90 degrees, so that means my shaded part is 90, and my radius is 4. So to find the area, I'm going to go pi. I'm going to multiply that by 4 squared, and then I'm going to multiply that by the fraction 90 over 360. Working that out on my calculator, 90 divided by 360, I'm going to divide that out first. Then I'm going to multiply that by 4 squared, which would give me 4. So my answer is 4 pi. So that would be my area of number 16. This one doesn't have measurements, so I'm not going to write in the measurements. Okay, number 17, we're finding the area of that 36 degree shaded part. So that means my arc, my measure of my arc is 36 degrees, and my radius is 6. So to find the area of the shaded sector, I would go pi. I would multiply that by the radius, which is 6 to the second power. And then I would multiply that by the fraction 36 out of 360. That's the fraction of the shaded part the circle actually is. Okay, dividing out the fraction, I like to do this first. It just seems to work out easier for me. I get a decimal, and then I'm going to multiply that by 6 to the second power, which gives me 3.6 pi. So number 17, 3.6 pi. Okay, number 18, I have noticed my arc is 45 degrees, or my shaded part is 45 degrees, and my radius is 3. So to find the area, I don't know if you can see this at all. It's got like this yucky glare on it. Huh. I don't know what's going on with that. Maybe if I hold on 1 second, I'm going to walk over. My microwave just went off. I was heating up some albondigas, which my wife bought for me at Toledo's on Friday. All right, so oh, that was pretty good, that albondigas right there. Okay, so to find the area of the shaded part, I'm going to go pi times the radius, which is 3, squared, times the fraction that the shaded part is, which is 45 degrees out of 360. Dividing out the fraction, 45 divided by 360 gives me that decimal there. Then I'm going to multiply that by 3 to the second power. So I get 1.125 pi for the area. 1.125 pi. Okay, number 19. So now I'm finding the area of this shaded part, and if you see the shaded part is 2 shaded parts. Well, that means since that arc is 45 degrees, and that's 90, so that's 90 degrees, so that means my entire shaded part is the 45 plus the 95, which is 135. And my radius is 2. So to find the area of the shaded part, I'm going to go pi times the radius, 2 squared, times the fraction, and then my fraction is going to be the shaded part, which is 135 out of 360, because that's a whole circle there. Okay, dividing the fraction out, 135 divided by 360 gives me that decimal. I'm going to multiply that by 2 to the second power, 1.5 pi for number 19. Okay, moving on to the back side here. We've got a couple more to go. Number 20. All right, so number 20. Notice I'm finding the area of the shaded part, but the unshaded part is 72. So that means the shaded part right here is going to be 180 minus 72. So 180 minus 72 is 108. So that means this unshaded part is 108 degrees. So to find the area, I'm going to take pi. I'm going to multiply it by my radius. Now be careful here. The diameter is 10, so my radius is 5, squared times the fraction 108 out of 360. That's the fraction of the circle I'm finding the area of. Okay, dividing that out, 108 divided by 360 gives me 0.3. Multiply that by 5 to the second power, and I get 7.5 pi. I'm just going to leave my answer in terms of pi here. 21. So you can see I'm finding there the shaded region. First of all, my radius is 6 because my diameter is 12. So the shaded region is 120. It's not 120, that's the unshaded part. But we know that this is half a circle. So that means if this is 120, this has to be 60 degrees because 60 plus 120 is 180. So to find the area of the shaded part, I'm going to go pi times the radius, which is 6 to the second power. Then I'm going to multiply that by the fraction 60 out of 360, or over 360. Okay, dividing out the fraction first, 60 divided by 360 gives me that yucky decimal. Don't round it, we're not done. Then we multiply that by 6 to the second power, and we get 6 pi. So my area of number 21 is 6 pi. Number 22, you could see, so first of all, my diameter is 6, so that means my radius is going to be 3, and then you could see the entire shaded part that I'm finding the area of, it's the entire circle except for that 45 there. So 360, which is the entire circle, minus 45 gives me 315. So that means my shaded measurement is 315 degrees. Okay, so now to find the area, I'm going to take pi. I'm going to multiply it by the radius, which is 3 to the second power. And then I'm going to multiply that by the fraction 315 out of 360. Okay, so now when I work that out, 315 divided by 360 gives me that decimal. Multiply that by 3 to the second power, and my answer is 7.875 pi for number 22. 7.875 pi. I'm not multiplying out the pi. Why am I not multiplying out the pi? Because notice right here it said leave your answer in terms of pi. That means don't multiply the answer out in pi. Okay, so here we go. Last one here. The shaded part would have to be 120 because that part right there would have to be 60. So I would take pi, I would multiply it by the radius. The radius is 5 to the second power. Then I would multiply it by the fraction 120 out of 360. Okay, dividing out the fraction 120 divided by 360 gives me that long decimal. Multiply that by 5 to the second power, and we get 8.3. And I'm going to round this. That's going to be my final answer. So I'm just going to say 8.3 pi. Okay, there we go. So there's how you find the area. Okay, 24 through 27, we're going to do some word problems. So the wheels on Reggie's bike tire have a 20-inch diameter, and his sister's mountain bike has wheels that have a 26-inch diameter. Okay, so we have Reggie, and then we have his sister here. To the nearest inch, how much further does Reggie's sister's bike travel in one revolution? So remember, when we're finding revolution, what we're really finding is we're finding the circumference of the circle. Okay, a revolution is how far would the tire roll forward in one full circumference. And remember, the way to find circumference is you take the diameter, you multiply it by pi. So Reggie's bike has a 20-inch diameter, so that means Reggie's circumference of his circle would be 20 pi. His sister has wheels that have a 26-inch diameter, so his sister's bike would have a diameter of 20, or a circumference of 26 pi. So how much further does Reggie's sister go? So to find the answer, we would take Reggie's sister's circumference, subtract it from Reggie's circumference. That would give me 6 pi. Okay, that's the answer. And if you leave that as the answer, that's good. Now, if you want to multiply it out using the approximation of 3.14 for pi, you could say the answer is 18.84. Okay, so either answer would be acceptable. Okay, number 25. On a Ferris wheel has a 50-meter radius. How many kilometers will a passenger travel during a ride if the wheel makes 10 revolutions? Once again, what does revolution mean? Revolution means circumference. To find circumference, you take the diameter of the circle, you multiply it by pi. Okay, so how would I do that? Well, what's the diameter of this Ferris wheel? Well, it has a radius of 50 meters, so that means the diameter is 100. I would multiply that by pi. So 100 times 3.14, I'm going to use 3.14 for pi, I get 314. So my circumference is 314 meters. Okay, so that would be how far it would go in one revolution, but I'm doing 10, so I have to multiply by 10. So my answer is 3,140 meters. Okay, so that's what we would have for 25. 26. A school is planting a circular garden. If the diameter of the garden is 6 feet, what is the garden's area to the nearest tenth of a foot? So we're finding area. So to find area of a circle, you take the number pi, you multiply it by the radius to the second power. We are told that the radius, the diameter, notice it says the diameter is 6 feet, so that means my radius is 3 feet. So to find the area, I would go pi times 3 to the second power. Okay, and then once I get that, I could just work it out on my calculator. So pi, I'm going to use 3.14 times 3 to the second power gives me 28.26. And it said to the nearest tenth of a foot. Well, the 2 is in the tenth spot. Remember, the first number immediately to the right of the decimal is the tenths, so the 6 would round that up. 28.3 would have been the acceptable answer. Okay, feet. Last one, number 26. An apartment complex is replanting grass seed in the play area. The area is a circle with a 30-foot diameter. Okay, they need 1 pound of grass seed for every 300 square feet. Find the area and then calculate how many 1 pounds of grass. So to find the area, I'm going to take pi. I'm going to multiply it by the radius to the second power. The radius of the play area, it has a diameter of 30, so that means the radius is 15. So pi times 15 to the second power, so 3.14, times 15 to the second power tells me I have an area of 706.5 square feet. Okay, then I'm going to divide that by 300 square feet. Now, why am I going to divide by 300 square feet? Because I know 1 pound of grass seed for every 300 square feet. I want to figure out how many pounds of grass bags do I need. So I'm going to take this answer, I'm going to divide it by 300, and that gives me 2.355. Okay, well, you cannot go and buy 2.355 bags, so we're going to have to round that up, and the appropriate answer would be go buy 3 bags of grass seed. Okay?